Here we'll look at an example of direct variation. We're looking for keywords, something like y varies directly as x, or maybe that y is directly proportional to x. So when you see either of those key phrases, you're going to know to use the direct variation formula, which is y equals k times x. Now, that formula isn't always going to use y and x. It's going to use whatever variables are in your problem. So, for example, if you had a problem that said something like a varies directly as h, then that means instead of y and x, you would use a and h. And whichever one is listed first would take the place of y, whichever one is listed second would take the place of x. So if I said a varies directly as h or a is directly proportional to h, I would write a equals kh. So we're looking for that key phrase and then using that formula, replacing the variables for whatever's relevant for that problem. All right, so let's look at the first problem here. And the way I like to approach these problems is I like to just read them a little bit at a time. I kind of stop every time I have a punctuation mark. So every time I get to a comma or a period or something like that, kind of stop and assess what I can get from that information. So if I just start reading here, it says the number of cars produced in a factory varies directly as the number of workers at the factory. And then there's a period here, so I'm going to stop at that point. So I'm seeing the key phrase varies directly, so that means I'm going to use that formula y equals k times x, but in this case it's not going to be y. This says the number of cars produced is what varies directly as the number of workers. So you can use whatever variables you want, but I encourage you to use variables that will remind you of what they actually stand for. So like instead of saying like cars is A and workers is B, it might make sense to use C for cars and W for workers. So in this case, that means if C varies directly as W, then I would write C equals K times W. So just from that first sentence, I was able to get that information. And I stopped at this period, so that's where I'm going to resume reading. So if I read until I get to the next punctuation mark, it says, if 200 workers can produce 60 cars, and there's a comma, so I'm going to stop there and see what I can come up with. So 200 workers can produce 60 cars. That's telling me that I can plug in 200 in the place of W, and I can also substitute 60 in the place of C. And that's enough information to actually solve this for K. So since I'm multiplying by 200, I could get rid of that by doing the opposite, dividing both sides by 200. And then when we do this, we could do 60 divided by 200. If you get a calculator, and then you could just get a decimal for that. If you get a decimal, if that decimal does not terminate, so if it repeats or if it's just really long and you have to round it, don't round it. So what I would do is I would just simplify this fraction, 60 over 200, or use your calculator to get that as a fraction. In this case, this is 3/10. So on this one, that would have been 0.3. So it wouldn't hurt you on this one to use that. But again, if you don't get a nice decimal like that, something that is longer or that repeats, you do not want to round because then it's going to throw off the rest of your answer. So this is pretty typical of this type of problem. What you'll typically do is you'll have like two parts to this problem. So the first part is where you find K, which is called your constant of proportionality, right? And so K is a constant, meaning it's not going to change throughout this problem. Now, our values for the other variables, they might change. So in the first half of the problem, I might have a certain value for number of cars or number of workers, but in the second half of the problem, those values might be different. What I plug in for C and W in this case might be different in the second part of the problem versus the first half. But K is constant. K is not going to change. So from this, once I do the first half of my problem, I can rewrite my original equation, C equals KW, but now I know that K is 3/10 or 0.3. So I've got C equals 3/10 W. And I had stopped at this comma. So I'm not even done reading the problem yet. So let me read the rest here. So it says determine how many cars 240 workers should be able to produce, and then that's the end of this problem. So how many cars 240 workers should be able to produce is wanting me to find C, but it's telling me what to plug in for W, in this case 240. So I could do 3/10 times 240 or 0.3 times 240. Let's see, if I just take 240 and divide it by 10, that's 24. And then if I multiply that by 3, that would be 72. So however you work that out, you should be getting 72. And this is a story problem, so that means you should include units in your answer. So in this case, the units is 72 cars. So in my first half, I went through the process of finding K. I used different values for C and W than what I used in the second half. In the second half, I used the value for K that I found to find what they were asking for, which is 72 cars.